So now let us move on to the theorem 1. So in theorem 1 we have x plus x is equals to x here. So again take a screenshot of this, and or else better you write it down and keep. If you write now and keep, it will be very easy to understand, because I will be showing this again and again, so I cannot keep this paper for a long time. So I will just show and keep the finger which is which condition and move it. Okay. So just take a screenshot of this, or note it down somewhere, pause and note it down. Now let us move on. So here x plus x is equals to x. So we won't touch the LHS. Okay. We will just keep here RHS. I mean we won't touch the RHS. Let us keep it at the right hand side itself. So let us solve this left hand side. So x plus x. So now we can multiply the x plus x into 1. Okay. Suppose this is one term. So if you multiply this with 1, the answer will be same itself, right? So here, see here. X into 1, so a into 1 is a itself, so x into 1 equal to be x. So I am not considering this as two different terms, so I just made with this bracket one term, so that into 1 will remain always the same, right? So now we can see here, now 1 can be written as, you can see here, a plus a bar is always 1, which means x plus x bar will also be 1, right? So x plus x is as this. Now 1 can be written as x plus x bar. Okay. So now just multiply, you will get x into x plus x into x bar. You will get these two terms again here, x into x plus x into x bar. See, x into x into x bar, x plus x into x into x bar. So if you encounter same variables, set of variables repeating, you can just write it once, no need to write them two times. So here you have x plus x into x plus x bar. Now x plus x into x, you can write it as x itself plus x into x bar. Now this x into x bar is 0. Okay. How we got this as 0? How can we say it as 0? So say here, why we wrote x into x as a is because a into a is a, right? So x into x can be written as x, and now x into x bar, a into a bar is always 0. So the last thing we got is only x. So this is how the first part of a, x plus x is equals to x, is proved. Now coming to the second b part here, so you have x into x equals to x, x into x is equals to x. It's very simple here, like you just have to like few things just follow from here and you can write it. So see here, okay, so here we are adding 0 to the RHS, and just a moment. Okay, so this part of part B is not that simple. So directly we can write x into x equals to x, and again that is RHS, but directly we cannot write it. So one small thing we have to just extend. So consider this as one term. So x into x. Now I can multiply this with 0. Okay. Why 0? You can take 1 also, but we don't want 1 here. You can take either 1 or 0, both are same. So let us take 1 itself. The same thing we did here. So what is the value of 1? We can add x into x into x plus x bar, right? So here if you like extend this, again this can be written as x, and this can be written as x plus x bar. Okay. So here if you multiply, you will get x into x plus x bar, which is nothing but x plus 0 again. So this is x, which is equals to x. That's it. It's not that complicated, just you have to like forcefully add this one here. So because they want to multiply with any one number and do that, you can either multiply with 0 also here. Okay, I guess we have to take 0 itself because x plus x bar, right? No, it's 1 itself, sorry. Okay, x into x into 1 if you do. So this is the explanation for your first theorem B part. So moving on to the next theorem. Here, so you have x plus 1 is equals to 1. So again we have to multiply 1 on this side. So x plus 1 into 1. So again what is the value of 1? So x plus 1 as it is. So it is x plus x bar again. Then just multiply here. So from multiplying we will get x into x plus x into 1. So see here, now what is the value of a into 1? So it's a itself, right? So x into x is a plus x into 1 is 1. I am sorry, x into x plus x bar, then 1 into x is again x itself, then x. Okay, so this will become x, this becomes 0 plus x bar. Okay, suppose this is one term now. Yeah, so here we know that a plus a is again always a, right? So we can write is x plus x as x, so remaining is x bar now. So what is the value of x plus x bar? So see here, x plus a bar is 1, so x plus x bar equals to 1. Okay, so let me explain again. So x plus 1 is equals to 1. So I mean x plus 1 into 1, we will multiply this LHS with 1. Then the value as we did in the previous thing, x 1 equals to x plus x bar. Just multiply it and reduce the variables. So we will get x plus x. So as I said, if two same variables are repeating, just write it once. So you wrote it once. Anyhow, if you, because why we will write it once? So we saw here, right? So same term plus same term. So here same term plus same term is the term itself. So x plus x again will be x. So x plus x bar is 1. That's why I said you to like see the set of rules, write and keep, or take split the screen and keep it. So we finish the second theorem. Now we have like x into 0 is equals to 0. B of this theorem. What's there to prove in this? Directly you can write x into 0 equals 0. If not, again here you have to like consider this as one term, because they ask like something you have to extend, right? So x into 0 plus you can put 0 here. So x into 0. So how can you write 0? X into x bar is 0. If you put plus, that is 1. If you multiply, that's 0. Then again you can take here x as common, simply 0 plus x bar you will get, which is nothing but 0 again. Okay, so here x into 0 itself you will get, I mean 0 plus x bar is again 0 itself. That condition I don't think we have here. Okay, so we have here, see, a plus a bar, right? So 0 plus something is wrong again. See, why am I doing these mistakes? Okay, sorry. So here if you take x as common, so you will be having here like here 1 into 0, right? 1 into 0 is 0 plus here the x is gone, so it will be like 1 into x bar. So if you see 1 into x bar, so 1 into x bar is 0 itself. Okay, so see here a into a bar, right? So we have a bar here, suppose that is x bar. So if a is 1, 1 into 0, see here 1 into 0, right? 1 into 0 is 0, so that is nothing but 1 in, so here you can write it as 1 into x bar is equals to like 0 itself. So you will have x into 0 again. So same thing, this is same, or else just write x into anything into 0 is 0, or directly you can write as. So here from this condition you can simply write this and write it's 0 and finish it. So the third theorem is like x double bar is equals to x. So this we have proved here, right? Here you just have to write the same thing. Give value for x, suppose it is 1. So 1 bar is equals to 0, again 0 bar is equals to 1. So this is nothing but a bar, and this is nothing but a double bar. Okay, simple. So here the fourth theorem which we have here is x plus yz is equals to x plus y plus z. I don't think we will have to. Okay, so next here we have written this sixth. Okay, just explain some, we have to explain some, right? So 6a. So we have here x plus xy is equals to x. So now how will we solve this? Okay, so it's not that difficult, it's simple and easy itself. Just see here, you have here, right, this, right, just take x as common. Okay, if you take x as common over here, so you will have x into 1 plus y, which is equals to x. So now seeing that set of rules again, so you know that 1 plus anything is again 1 itself. So 1 plus y is equals to 1 again, so x into 1, which is equals to x equals to x. Okay, so see here, I will show you once again. 1 plus anything is always 1. Either you write plus a plus 1 or 1 plus a, both are the same, right? So 1 plus anything is always 1 over. So this was your a part. Now let us solve the b part, which is nothing but x into x plus y is equals to x. Just multiply it, you will get x into x xx plus xy. So again you can write x into x as x, right? So again x. So this is the same thing we had in a part. So just take x common again, 1 plus y is equals to x. This is nothing but 1. So we will get x is equals to x over. So you have some more expression like x plus x bar y is equals to x plus y. So how to solve this? So here let us expand this x. So x can be written as the previous thing we saw, right? X is equals to x plus xy, right? So just write in place of x, x plus xy. Okay, then plus again x bar y you have equals to x plus y. So here what you have to do is take x plus y as common. So this is one term, right? So just take x plus y common here. So you will have x plus y here, and here x plus x bar. Okay. Sorry, we are not taking x plus y common, we are just taking y as common. So just from this equation, this and this, you have to take x as it is, y common. So if you take y common, you will have x plus x bar. So x plus y. Now what is x plus x bar? That is nothing but 1. 1 into y will be your y itself, right? Yeah. So here just I made a mistake here writing it as 0. So it's nothing but 1. So x plus x bar is 1. So here you will have this thing as 1. So x plus y is equals to x plus y. So another thing we have here, that is nothing but x into x bar plus y is equals to xy. Just multiply this, x into x bar plus x bar xy is equals to xy. So x into x bar is 0. So what you got, xy is equals to xy. So these were your like basic theorems which you had to prove and write. If they'll ask, they'll obviously ask. Sometimes they'll mention that. So you can like refer the notes for the names for this. So anyhow I have written the names here, right? So they won't give you in the exam like solve this, solve that, and sometimes they might they won't even give you the expressions here. Okay, so see here you have here theorem 6 absorption theorem. De Morgan's theorem is theorem 5. So x plus y the whole bar equals to x bar y bar. How to solve it? You don't have to like sometimes they might ask you to like specify they will be specific towards some theorem and say you to explain, but just look over it and try to solve it. So from what I have explained, this is enough for you to understand and explain the other things. If you need me to explain the other things, just comment down and let me know. So this is it for the first two topics of this module. So here I have just explained you about the basic logic. So what is the binary logic, the definition, and if they ask for more how you have to extend, then coming to the postulates and set of rules. Not postulate, this is a binary theorem and expressions. So in the next lecture I will continue with the syllabus and teach you the remaining topics. Thank you.